All right, so if you're getting this video, this is for the 5.1 lab, the chemical activity of metals. And I'm going to make another video that actually shows these chemical reactions taking place. But that way it can be kind of full screen rather than this little box in the corner. So with this lab, what we're doing is we've been talking about the periodic table. Now we understand, okay, we know vertically atoms or elements are organized in their groups. And then horizontally, they're organized in their periods. And we can number each of those and identify where each atom is. Then, after we went through and looked at the Bohr model of the atom, where we see all the energy levels and all the electrons, we started to notice a trend. We started to see that elements that are in group one have one valence electron. And again, valence electrons are just the electrons in the outermost energy level. So then we saw in group two valence, group three valence, four valence, and so on. So then we started looking at the Lewis structure. Okay, so we can draw a Lewis structure, which then is just, instead of including all the energy levels and electrons, we're just going to see those valence electrons. So now, progressing from there, we're going to look at the chemical activity of metals specifically. So we want to know what makes something reactive, okay? Because not all elements or atoms behave the same, right? Some are very highly reactive, other ones are not so much. And so that's kind of the purpose of this lab, is we're going to see if we can figure out a way to rank these metals as far as reactivity. And then we're going to look at where they are on the periodic table and see if we can see any trends. Okay, where do we find the most reactive elements? Where do we find the least reactive elements? Okay. So with this, again, just make sure we're doing our labs in our notebooks. Okay, getting the title, lab number, your name, our purpose slide. Okay, so if you need to pause the video, go ahead and do that and write down your purpose slide. The hypothesis then is you're just making a guess, right? We have these four metals down here. So we have sodium, aluminum, magnesium, and lithium. And so you're just taking your best guess at which one do you think will be most reactive. So some people said, oh yeah, the lithium, because it's highest on the periodic table. Some people said aluminum because it's lowest, it's the heaviest element that we have. Some people said sodium because it's on the left. Whatever you think, you don't have to have a real good reason right now, but the way we'd structure our hypothesis is, if I test the four metals, then aluminum will be the most reactive because it starts with an A. Okay, we're just making a prediction here. Okay, and so you can see what we're going to be doing is basically we're going to start with adding water to these atoms to see if they react. Then we have a weak 1 molar hydrochloric acid, and then finally we have a strong 6 molar hydrochloric acid. Now, why do we have these different things? Let's think about this. If you put something in water and it reacts and fizzes and bubbles, that would be a pretty good indicator that that element is very reactive, right? Now, if it requires a very strong acid to actually get it to react, that would mean it's unreactive. So we want to think about that as we're filling out our data tables. What are we seeing? The most reactive elements are going to react when we put them in water. The least reactive elements are going to react or aren't going to react until we put them in a strong acid. Okay, so now last thing with our data table, what we want to do here when we copy this into our notes is, in each of these, you're recording your observations. Okay, so that's what it means by description of reaction. So if sodium doesn't react to water, you just say no reaction, or Na. If it fizzes, you'll say fizzing, bubbling, warming up, heating up, all these indicators of chemical reactions. So you're going to tell us what we saw, and that's going to help us create our ranking here at the end. Okay. Then when we go through, just to kind of preview, with the analysis, okay, we're going to draw a little periodic table, just a mini one, okay, and then we're going to, or you're going to make a bar graph and rank the reactivity. So most reactive to least reactive. Then this one is where we're going to draw a little periodic table, and then we're going to try and place the four metals in their roughly their location, right? So sodium and lithium over, and magnesium over on one side, aluminum's kind of over in the middle, and then we're going to draw an arrow based on our findings in the direction of increasing metal reactivity. So if they increase as it goes down, that arrow is going to point down. If it increases as they go up, you're going to do that. Okay, so that's what this means. And then finally, we're going to start to look at how many valence electrons do these things have? What patterns do we see? And what do we notice when we get to the noble gases? So that's just going to be looking at your periodic table, understanding valence electrons, okay? So now what I'm going to do, we're going to go ahead and end this video, and then I'm going to start a new one, and that's going to actually show these reactions.